All right, today we're going to learn about solving polynomial equations, and this is our content standard and mathematical practice we'll use in our assignment today. Previously, you've solved quadratic functions by factoring, and now we're going to factor polynomials and solve polynomial equations by factoring. New vocabulary for today: prime polynomials and quadratic form. Some cubic polynomials can be factored with special rules. You might want to write these special rules in your notes. So when we did the factoring earlier, we haven't really got to factoring of sum and differences of cubes. So we're going to cover that in this lesson. Notice that the sum of two cubes, a cubed plus b cubed, can be written using this pattern: a plus b times the quantity of a squared minus ab plus b squared. And the difference of two cubes uses this pattern: a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay, so let's look at some examples. We are asked to factor this polynomial, x cubed minus 400, and if the polynomial cannot be factored, we're to write prime. Well, we know the first term is a perfect cube. This is x times x times x, but 400 is not a perfect cube. There's not a number that you can multiply by itself 3 times to get 400. So it is a prime polynomial. We're to factor this one. Well, first thing I notice is a 3 goes into both of these, and x squared. So we need to first factor out the greatest common factor, 3x squared. That leaves us 8x cubed plus y cubed. Now we've got some perfect cubes. So we can factor 8x cubed is 2x cubed, and y cubed is y cubed. So using our pattern, 2x plus y times the quantity of a squared minus a times b plus b squared, if you list 2x as a and y as b. Then we simplify. So our answer is 3x squared times the quantity 2x plus y times the quantity 4x squared minus 2xy plus y squared. Okay, time for you to check your progress. First of all, ask yourself, is there something that I can factor out? And if not, could this be prime? Very good. You notice you could pull out a 2x squared to begin with, and then you've got some perfect cubes. So our answer is A. 2x squared times 3x plus 4y times 9x squared minus 12xy plus 16y squared. Let's try another one of those. So pause and then come back and check your answer. And you're right, this one's prime. Could not be factored. This table summarizes the most common factoring techniques that are used with polynomials. So whenever you factor a polynomial, always look for the greatest common factor, some common factor first. Then determine where the resulting polynomial factors can be factored again using one or more of these methods. So do you have a difference of squares, sum of cubes, difference of cubes? Is it a perfect square trinomial? And then if there are 4 more terms, you can solve by grouping. This is some things that you might want to put down in your notes. So why don't you pause and make a note of these factoring techniques. Okay, let's use some of those factoring techniques by factoring by grouping. So notice we have 4 terms. There is not something that comes out of all 4 of them. So we're going to group them together. Out of these 2, I'm going to pull out an x squared, and out of these 2, a negative 2. Because we want what's in the parentheses to be the same. Using the distributive property, we have x plus 5 times the quantity of x squared minus 2. So that is our answer. Let's try another one of those. Here again we have 4 terms. Is there anything that comes out of all 4? No, so we're going to group them. And then we're going to factor our groupings, wanting the same thing to end up in the parentheses. So we have a plus 3y times a plus 2y squared. And that is our answer. Okay, time for you to check your progress. So factor this polynomial, then come back and check your answer. Did you get d plus 2 times d squared plus 4? Excellent. If not, go back and rework that. See where you might have made your mistake. Let's try another one. So pause and then come back and check your answer. R plus 2s times r plus 4s squared. Very good. Factoring by grouping is the only method that can be used when factoring polynomials with 4 or more terms. For polynomials with 2 or 3 terms, it may be possible to factor according to one of the patterns listed previously. When factoring 2 terms in which the exponents are 6 or greater, look to factor perfect squares before factoring perfect cubes. So let's look at this one. We have 1, 2, 3, 4, 5, 6 different terms. So we're going to factor by grouping first. So we group the first 3 and the second 3. And is there something that pulls out of all of these? Y to the third is common amongst all these terms, and z to the third is common among these 3 terms. So we have y cubed plus z cubed times x squared minus 3x plus 2. We're not done factoring yet. We've got some perfect cubes here. So this, using our pattern, factors y plus z times y squared minus yz plus z squared. This one factors yet again, x minus 2x plus 1. So that is our total answer. It's very important that you keep working down your paper, not all over the paper. Stay nice and neat so you can determine where you are. Let's try another one. We're to factor 64x to the 6th minus y to the 6th. This polynomial could be considered the difference of 2 squares or the difference of 2 cubes. The difference of 2 squares should always be done before the difference of 2 cubes for easier factoring. Okay, so difference of 2 squares, 8x cubed minus y cubed and plus y cubed. Okay, so plus and minus. We got a difference of 2 squares. Okay, so then we factor 2x plus y times 4x squared minus 2xy plus y squared. And then 2x minus y times 4x squared plus 2xy plus y squared. So we've got a sum and we've got a difference of the 2 cubes that we're factoring. And that is our total answer. Okay, time for you to check your progress. So work through the problem, then come back and check your answer. Okay, so you group 6, or group 3 and then the other 3. This one you can pull out an r cubed, this one a y cubed. Do your difference of squares first and then your difference of cubes. Let's try another. (3p minus k). So we did the difference of squares and then we did the difference of cubes. Okay, you can use factoring and the zero product property to solve polynomial equations just as you did with quadratic equations. So let's look at this problem. We are to find what? Determine the dimensions and the volume of the shaded figure. Okay, so we're just wanting the volume of the shaded part, which means we have to find the volume of the whole thing and subtract out the volume of the part that's not shaded. So we have 2x cubed minus x cubed, and we're told it equals 23,625. Okay, 8x cubed can be rewritten as 2x that has been cubed. Okay, so we do our subtraction. 8x cubed minus 1x cubed is 7x cubed. Divide both sides by 7. Then subtract 3375, and we've got some difference of cubes here. 15 times 15 is 3375. For times 15 cubed, I'm sorry. Set each one of these equal to 0 and solve for x. And this is an imaginary number, so this can't be the measurement of a box because it's an imaginary number. The only number that would be a real solution would be 15. So since x is, one solution is x and the other side is 2x, the lengths of the cubes are 15 and 30 centimeters. Okay, so time for you to check your progress using the same kind of process that we did on the example. Okay, very good. 9 and 18. So I had 2x cubed minus x cubed is equal to 5,103. So 8x cubed minus x cubed equals 5,103. 7x cubed is equal to 5,103. Divide both sides by 7. I have x cubed is equal to 729. I subtract 729 from both sides. That factors x minus 9 times x squared minus 9x plus 8. And so 9 is the one that doesn't come out with an answer that doesn't fit length. So our lengths are 9 and 18. In some cases, you can rewrite a polynomial in x of x in the form au squared plus bu plus c. For example, letting u equal x squared. So here we're going to let u equal x squared, because that's pretty confusing, x to the 6th, isn't it? The expression x to the 4th plus 12x squared plus 32 can be written x squared squared plus 12x squared plus 32, or u squared plus 12u plus 32. This new but equivalent expression is said to be in quadratic form. Here's our quadratic form. So when we've got x to the 6th and x to the 6th here, we want to make it squared. So we're going to have u equal 2x cubed. So we're going to substitute a u in for 2x cubed so it's in the quadratic form, and then we go back and plug it back in the original expression. Let's see what that looks like in an actual problem. In this problem we have 2x to the 6th minus x to the 3rd plus 9. So if we were to rewrite this in quadratic form, x to the 3rd squared and x to the 3rd, okay, let's rewrite this one in quadratic form. Oh, we can't do that because x to the 3rd isn't anything squared. That doesn't come out, does it? X to the 4th can't be something squared. Okay, so that one cannot be written in quadratic form. What about this one? Can we write it in quadratic form? Can we make it something squared? You bet we can. We have 6x to the 5th squared, okay, because 5 times 2 is 10, and minus 2x to the 5th minus 3. So notice we have x to the 5th in both parentheses. Here, which one of these would fit? Can it be written in quadratic form? Well, we have this problem when we have an 8 and we have a 3. We can't break it down. This is, no, that's 16. This is 8, but not the same thing as in the parentheses. This is 8, but that's only 2. So this one cannot be written in quadratic form. Now let's use what we know about quadratic form in order to solve equations. X to the 4th is x squared squared. So we're going to have u take the place of x squared. So it's in a format we're used to working with. So we have u squared minus 29u plus 100. So we can factor this. Factors of 100 that add up to be 29 are 25 and 4. Same sign, both signs negative. So we set them both equal to 0. So we add 25 and add 4. We get 25 or 4. Now the thing is, we're not done because we're not solving for u. we've got to solve for x. Well, we let u be x squared, so now u is going to be x squared. We substitute it back in, and so then we take the square root of both sides because we solve for x, not x squared. So our answer is plus or minus the square root of 25 and plus or minus the square root of 4. Well, the square root of 25 is 5. The square root of 4 is 2. So we've got 4 solutions, plus and minus 5, and plus and minus 2. Okay, so now time to check your progress. Okay, so we're going to let u equal x to the third. So 3 times 2 is 6, and then there so we're going to have u squared minus 35u plus 216. So our factors are u minus 27 and u minus 8. So we end up with substituting our x cubed back in for u. X cubed equals 27 and x cubed equal 8. So x is equal to 3 and x is equal to 2. Very good. You're ready to begin your assignment.